All right, welcome to The Explainer. Today, we're diving headfirst into a really heated debate, one that's shaking up tech teams everywhere. We're talking about the rise of the AI engineer and why, just maybe, that whole title is a giant mistake.
So, this is the big question on every engineering leader's mind right now, isn't it? Do I need to hire an AI engineer? The pressure to do AI is just massive, and it's created this flood of new, kind of confusing job titles. And the biggest one of all? Yep, the AI engineer.
And look, let's be super clear here. This isn't just about hiring somebody. You're standing at a fork in the road, and it's a big one. The path you pick is going to define your team's ability to innovate, the reliability of your product, heck, maybe even the success of your whole company in this new AI era.
Okay, so let's talk about those two paths. One way to go is to chase the hype, right? You create this shiny new AI engineering department and just kind of bolt it onto the side of your organization. But there's another path, a much more sustainable one, we'd argue. And that's all about evolving the incredible team you've already got.
So let's just cut to the chase. This belief that you need a whole separate profession called an AI engineer. It's a myth, and honestly, it's a pretty dangerous one. So today, we're going to tear that myth apart. We're going to deconstruct what this role really is.
You know, what's really interesting is this isn't the first time we've been here. We've seen massive tech shifts like this before. The playbook for how to handle it, it already exists. You just have to know where to look.
Think back to when relational databases completely changed the game. Did we spin up a brand new PostgreSQL engineering department? Of course not. We saw it for what it was, a super powerful but new specialization. Software engineers learn database skills, and that's the exact same logic we should be applying today. AI isn't a new profession. It's a new specialization inside the good old craft of software engineering.
And this right here, this gets to the absolute heart of the issue. For most companies out there, the real challenge isn't inventing brand new AI models from scratch. No way. The real hard part is taking these incredibly powerful but also kind of flaky and unpredictable AI components and integrating them into a reliable system that actually works. And folks, that is a classic high-stakes software engineering problem.
Okay, so what happens if we get this wrong? What's the downside? Well, creating these separate, isolated AI teams, it might feel like a shortcut, like you're fast-tracking innovation. But what you're actually doing is taking a fast track to a whole new and really nasty kind of technical debt. See, unlike the code you're used to, which stays the same until you change it, an AI feature can break all by itself, silently, invisibly, right there in production. It's a thing called model drift, and it means a feature that was working perfectly on Monday could be spitting out total nonsense by Friday, with zero code changes and zero alerts going off. Scary stuff. And it gets worse. This problem is made even trickier by a principle called CASE. That stands for Changing Anything Changes Everything. In these super complex ML systems, one tiny little innocent change to a prompt, well, it can set off these unpredictable, cascading failures that ripple across your entire application.
So you put all that together, and what do you get? You get the new face of technical debt. We're not just talking about messy code anymore. We're talking about silent model drift, these cascading case failures, brittle glue code that just stitches things together, and these opaque black box models where debugging feels like pure guesswork. And when you create a separate AI team, you're basically building this problem right into your company structure. It creates this throw-it-over-the-wall mentality. One team builds the model, throws it over to the software team, and wipes their hands of it. So when it inevitably breaks in production, what happens? The AI team says, hey, it worked on our test data. And the software team says, well, the model's broken. And you're stuck in this blame game. This ownership gap, it doesn't just create friction, it literally architects future failures into your org.
Okay, so how do we avoid this whole mess? The answer isn't to invent a whole new profession. It's to adapt the timeless engineering playbook we already have. The goal is to take all that rigor we've built up over decades and apply it to this new world of unpredictable, probabilistic systems.
And we're not throwing out the baby with the bathwater here. We're just augmenting our core disciplines. So, testing, it's not just about asserting a specific outcome anymore. It's about testing for behavioral properties. Observability, it's not just about CPU and latency. Now you've got to add model behavior, cost, and drift detection. And security, well, you're still worried about SQL injection, but now you've also got to defend against prompt injection.
This right here is the key architectural idea you need to remember. You have to treat the LLM like a powerful but totally chaotic third-party service you don't control.
You wrap its unpredictable, probabilistic core in a deterministic shell of rigorous engineering. You isolate it, you contain its blast radius, and you never, ever fully trust it.
And to get that kind of rigor, we have to stop treating prompts like they're just some magic words we copy-paste from a playground. No, we have to treat prompts like code. And what does that mean? It means version control in Git. It means pull requests and peer reviews for every single change. It means automated testing in your CI pipeline and automated deployment. It means the whole shebang, a disciplined, professional software development lifecycle.
All right, so let's get practical. How do you turn this into an actual plan? Remember, the goal isn't to build another silo. It's to build a bridge that helps your team evolve their skills to meet these new challenges. First things first, don't join the frantic, super expensive hunt for AI engineers. Instead, invest in the talented people you already have. Upskill them. Focus your training on 3 key areas: solid data literacy, the practical, applied concepts of ML, and, this is crucial, treating prompt engineering as the serious technical discipline it is.
And what about your most senior engineers? Well, their role is about to change big time. It's becoming less about them writing lines of code and more about them being the skeptical human in the loop. They need to be your architectural guardians, the ones who critically review AI outputs, the ones who set up the governance that keeps the whole system safe and reliable. And finally, you gotta back up these new skills and cultural shifts by changing your processes, mandated. All AI assets, prompts, data sets, everything, they live in version control now. Update your team's definition of done so that any new AI feature must include probabilistic testing and drift monitoring. And please, start small. Run contained pilot projects to build up your knowledge and prove the ROI before you bet the farm.
So here's the bottom line. The future of building amazing products. It's not going to belong to some new priesthood of siloed AI specialists. It's going to belong to integrated teams. Teams that apply the disciplined, battle-tested craft of software engineering to this powerful new tool. The title software engineer isn't becoming obsolete. In the age of AI, it's becoming more vital than ever.